All right, what's going on, guys? Sorry I'm a little late. I had on a phone call. Today what we're going to go over is air masses and fronts. Okay, so that worksheet that I gave out on, I believe, Friday, it was supposed to be due on Monday. I know that you guys, it's a little bit tricky to be learning at home. I understand that, so we're going to go over this nice and slow. Okay, so what we're going to do is we're going to look at number one. So it says an empty air mass would most likely originate over which type of Earth surface? Okay, so really quick, telling us an empty air mass. All right. So remember, there's only a couple of different air masses that we find on Earth. All right. So M equals maritime and P equals polar. All right. So those are the two first letters that ever come up in an air mass. All right. Sometimes you get A, which is Arctic. All right. But generally it's M and P. Okay. Now the other thing is you either have a T or a C. All right. So you got T or you got C. So you got continental or and tropical. All right. So what happens is you can either have a C, an A, or an M at the beginning, and then you either have a P or a T behind. Okay. So basically, what number one is asking you is what is an MT? Okay. So an MT is a maritime, and it's a tropical. All right. So when we think about those two, we're thinking about basically it's going to be warm, right? Because tropical, we think of warm. And then maritime means that it's happening over the ocean, okay? Or a body of water. So maritime, ocean, usually there's going to be a lot more water vapor in the air. So it's going to be moist and warm. So for number one, our choice is going to be A. And I'm going to put that right there, okay? So that's for number one. Now let's see if we get rid of this and then we go to number two, okay? So number two, an air mass located over central United States is most likely going to move towards where? So if you look at the notes, right, we have a jet stream that goes across. It's basically all of our stuff, all of our weather comes from out west, okay? So if we have, let's say, a low pressure system and it's going to be heading, it's actually going to be going, because if we make our little compass, all right, we got north, south, and then we got east, and then we got west. It kind of goes up like this. So it's going to be northeast. So for number two, it's going to be D. Why do clouds usually form at a leading edge of a cold air mass? Okay, so the leading air edge, all right? Let's say we got cold air, okay? Cold air mass, all right? Now, we have a warm air mass, okay? Let's say this whole thing over here, this is warm air. So we know through this that usually cold air mass is going to go, it's going to sink underneath this warm air mass. But this warm air mass is going to rise, okay? Because remember, warm air rises and expands. Cold air is going to sink, all right? That's why you have your air conditioners up top. Cold air is going to come down, and then the warm air is going to go at top. That's also, you know, when you're learning when you're younger, smoke always rises. If a house is on fire, you always want to get low, okay? That's where the cold air is, or the cooler air. So it goes down, and because it goes up, right, you have that warm air rising at the front, a cold front coming in. it's going to form clouds. And when clouds are forming from air that's going up and expanding, you're going to get precipitation, okay? So the only one for number 3 that makes sense is cold air flows under warm air, causing the warm air to rise and cool. So number 3 is going to be C. All right, number 4. A high pressure center is generally characterized by, so let's think about a high pressure center. Okay, we've got a high pressure. We know that all the air is going out of it in a clockwise rotation, okay? So because of this, there's not going to be a lot of clouds there. It's pushing everything out. So we can eliminate right now A and D because it's saying wet weather. If there's no clouds, there's not going to be any precipitation because it's moving everything out, okay? Now also, which gets a little confusing, since the wind is blowing everything out, it's going to be cool, all right? So for number 4, it's going to be B. It's going to be cool, but it's going to be dry weather, all right? Number 5, a CP air mass would most likely originate over which type of Earth's surface? So let's get rid of our cold air mass and our warm air mass. And let's look at CP, okay? So C's and P is always capital. So I'm telling you that C is continental, all right? So we got continental. And we have a polar, okay? So when we think of polar, that's going to be a cold air mass, right? And then when we think of continental, that's land. So for number 5, it's saying air mass would most likely originate over which type of Earth's surface. So it's going to be cold. And a land mass, if we're thinking between land and the ocean, which one is going to be a lot drier? It's going to be the continent, all right? So it's going to be a cold and dry air mass. And that, for number 5, is going to give us B. And number 6 is basically reverse. It's saying which symbol would be used to identify an air mass originating in central Canada, okay? So remember, where we live in America, Canada is above us, okay? It's a little bit north. So when we think of Canada, usually it's a little bit colder than us, so it's going to be polar. And since we're talking about Canada, it's a country. It's located on a continent, so it's going to be CP. So it's basically CP is the type of air mass that you would find over Canada, and that is choice A. All right, number 7. Compared to the maritime tropical air mass, a maritime polar air mass has, so we are converting or comparing. They give us MT, all right? And then they also give us MP, okay? So we got 2 maritimes. We know that maritime is over the ocean. So both of these form over the ocean, okay? Now, we have a tropical and we have a polar. So tropical is going to be warm. Polar is going to be cold or cooler than the tropical, okay? So because of this, what is the difference between maritime tropical and maritime polar? So maritime polar is what compared to maritime tropical? Well, it's got to be lower in temperature because we're saying that it's polar. It's got to be colder, okay? So the only 2 choices that we can go with is A and C. But now there's another part. It's telling you has less water vapor or more water vapor, okay? So remember, when you have warm temperature, you're able to hold more water vapor, right? So the higher the temperature, basically more water vapor. So if we're looking at temperature, maritime tropical, that has more water vapor, okay? Where polar has less. So for this, for number 7, maritime polar has a lower temperature than maritime tropical and also has less water vapor because it's colder, okay? So number 7 is going to be A. And that's for that first sheet, okay? Now we're going to flip it over. Now they basically give us a picture of the United States and has a low pressure system in the middle of it, okay? So let me get rid of all this. And let me see. So they give us a low pressure system, okay? They give us this line that's coming out of it. And if you look at that line, it has these symbols, these half suns, okay? So remember, that's a warm front, right? I always remember it looks like half suns, okay? Now you have this other line that's coming down, okay? And it has these triangles, all right? I always think these triangles are icicles, so that's your cold front. So you got your warm front, and you have your cold front, okay? And whatever way those symbols are going, okay, is which way they're moving. So this cold front is actually going that way, and this warm front is going this way, okay? And this is the front of those fronts, okay? So everything behind here is warm temperature, a lot warmer than whatever the temperature is over here. The same can be said over here, okay? This is all cold air behind here, and whatever this is warm compared to this cold front that's coming in, all right? But for this case, they don't give us any of that. They're just giving us pressure, all right? So let's look at this for a second. They give us, you know, all these different lines going around, okay? And I'm just going to give you a couple of them, all right? So it's something like this. Now, they give you the pressure for some of these. So I'm going to give you, they give you 1,004, they give you 1,000, and then they give you, okay, 996. So these are the pressure for these different isotherms, okay? Now, number 8, the circular surface winds associated with the low pressure system. So what do we know about a low pressure system? It's always going counterclockwise, right? So if I was to put another one over here, here's my low pressure system. It's always counterclockwise, and it's going into it, okay? Now, if you notice how I'm making my cold front and my warm front, it's already going in a counterclockwise rotation, okay? If I use a different color, you have this cold front coming this way, and then you have this warm front going this way, all right? It's already spinning in a counterclockwise rotation. Now, the other thing is it's always going towards the center. This is where all the clouds are going into, all right? All the water vapor. This is where your storms are. So for number 8, it's going to be counterclockwise and towards the center of the low. So 8 is going to be letter C, okay? All right, so number 9. The air pressure in the center of this low system is what? So this goes back to what we learned about with our contour lines, okay? They give you these isotherm lines, all right, with different pressures. Now, if you notice, the difference between both of these, okay, is 4, all right? Then you go down again, it's another 4. They're asking you, what is the pressure in the middle of this low pressure system, okay? So they give you a couple of different options, all right? But you'll notice, since we're going to a low pressure system, what's happening to the numbers? They're actually getting lower, okay? That makes sense. You're going into a low pressure system, the pressure is going to be lower in the middle than it is to the outside. And it would be reversed if we were doing a high pressure system. So they give you a bunch of different options for this multiple choice. All right. So they give you, let's say, one of the choices is 1001. Okay. Now, the 1001 can't be in the low pressure system because 1001 is located over here if we were to put this in between numbers. All right. So it can't be that one. Now, they also give us 997. 997 would be located over here, still not in the middle. Now, the two choices that they give you, 991 and 994, both are below 996, okay? Now, the reason that we know that one of these can't be the answer is because what are these going down by? They're going down by 4, okay? So if there was another line inside of that, it would be 996, okay? So let's say if I made another one, all right? This is all fake. If I made another one going around, okay, that number would be 992. And it's the same method with contour lines. That means the inside would have to be something lower than 992. But because we don't have that line, it never goes down to 991. So the answer is actually 994, all right, which is going to be choice letter C. Which location is most likely experiencing the fastest wind speed? So for this, all we have to do is remember, it's the same thing with contour lines. The closer the lines are together, the greater the wind speed. So if you look at B, letter B, you'll see that those lines are very close together. Whereas if you look at letter D, it's in the middle and there's no lines near it. So D would actually have calm winds or no winds, and B would have very strong winds. So for number 10, the choice is going to be B. Okay. Which direction would the low pressure most likely move towards over the next few days? So this goes back to our other page. Since we have jet streams that are above, it's going to be traveling northeast. Okay. So 11 is going to be D. All right. So that's that other page. Now what we're going to do is we're going to cross over to the next page. All right. So I'll keep this for a second. And then any questions so far? Just going over it, making it a little bit easier. How are you, Evelyn? You missed the seventh grade one. That was at 12. All right, so number 12, it's saying the atmospheric conditions in eastern Nebraska are represented on the map by a station model labeled A. List all the weather variables below based on station model A. So this goes back to what we were going over last week. We have a station model, all right? Looks like this, it's got this going on, and then it has 50 and it has 45, okay? So this is the station model they give us for A. Now, the only thing is, if we use the reference table, right, just to make sure that we're safe, and we go to page 13, okay, there's actually a lot more information that they give us in the reference table than what they do on the actual map, okay? The map doesn't give us all the information that we need, but they're just asking us, what does it give us, all right? So we'll know that the top left is the temperature. So here's our temperature, right? It's going to be 50 degrees, okay? And since we're using the reference table, we got to know it's in Fahrenheit, all right? Now, the lower one, if we use the reference table, is our dew point, okay? And we got 44 degrees. And we make sure that we check it right, and that's also in Fahrenheit. So those are our two numbers that they give us, okay? Now, our station model is completely shaded in. So our cloud coverage, all right, is going to be 100%. Our next thing is we got to find the wind, okay? So let's make a little compass just in case so we don't make mistakes, right? North, south, west, east, okay? Our line falls in between southeast, so it's a southeast wind because the wind is coming from the southeast. It's a southeast wind. And our next one, the only other information that we can get from this, which is still a lot, we got our temperature, our dew point, cloud cover, and our wind, is our wind speed, okay? So we look at this, we have one line coming out. So that one line is actually equal to 10, okay? And our units for this is not miles per hour, it is knots, okay? So just that one part, that station model is able to pick up these 5 different sources of information, okay? And if you notice, a lot of them have the same information on it, just a little bit different, okay? So that's the first part. So that's number 12 for the short answer, okay? Now, number 13, compare to the temperature and humidity of the air on the east side of a dry line. Describe the temperature and humidity on the air on the west side, okay? So basically what we're going to do, we're going to erase this. See you later, Evelyn. We have our low pressure system again, okay? We got this, we've got 2 lines going around. Basically looks like what we were doing before, okay? Again, this is really quick, but we got our warm front, we got our cold front, and this is going that way, and this is going up, okay? It's going around a low pressure system. Now, we have this dry line that they call it, okay? Basically, it's as this cold front is coming up, it's all the air over here is warm, okay? It's raising it up, and then you're going to get some precipitation. So it's asking you from this, right, compared to this side of this dry front. So if you look at all of those station models to the left, you'll notice that a lot of them, the temperature is a lot colder over here than over here. So you can say it's colder, all right? And then the other thing is, when we're looking at station models, right, you can either have it filled in, you can have it halfway, or you can have it open. If it's open, that means there's no clouds. A lot of the station models on to the left has no clouds, so it's going to be no rain. And the other thing is, if you remember, the closer that the temperature and the dew point are together, the higher the humidity, okay? So if temp / dew point close in value, the greater the humidity. Okay, so if you look on this side, they're separated. So there's actually less humidity on this side than on this side, okay? And this would make sense because what type of air mass is over here? It's a warm air mass, all right? So it's less humidity, okay? And I'll bring that down. All right, so that was basically what we're going, or hopefully this helps you. I do understand that this topic is a little confusing to be doing at home, okay? If you do have any questions, just let me know. For the weekend, okay, you guys can relax. If you owe me anything, then get those done by Monday. We will go over the textbook questions on Monday, and then we will go from there, right? We're almost basically done with weather, okay? And then we're going to jump into astronomy in space. And then we'll do a little quick review, what we would have done if we were still in the classroom. Okay. I'll see you guys later. Take it easy.